name is Davis, and through this tutorial I like to walk through two main topics within Docker Swarm, which is basically monitoring and elastic growth. So in monitoring, we're going to launch a service called CAdvisor and Manomax Visualizer, and this is going to be a Docker Swarm service. So it's going to be hosted on all the nodes and present in the Docker Swarm cluster, and we will see exactly what these services does. And the next part of it is elastic growth, where we are going to use essentially Docker stats to poll every node and their container utilization, and if the load on the containers is high, then we're going to spawn more containers, and if the load is less on the containers, then we're going to decrease the number of containers. So this is what I mean by elastic growth. So let's get started. Yes, this is my master node, which is my Docker Swarm master. So let me do and initialize it to be the master. So yeah. So now it has generated a token for all the worker nodes. So I shall copy this command over to my worker nodes, and yes. So both the nodes, node 1 and node 2, has joined the cluster. Let me actually, before we get started, I shall show you a high level diagram of what I'm trying to achieve. So this is the master node, this is the IP for it, this is the two nodes, worker nodes, the IPs for it, and it is achieving internal load balancing as well as service discovery and all of these features, capabilities of Docker Swarm through this ingress routing mesh, and I shall show that to you just in a second. So now if I do docker node ls, I shall see that I am the master, and I have two worker nodes. And if I show docker network ls, you shall see that there is an overlay network called ingress, and this is what I meant by the ingress routing mesh. So whenever I host a service which is going to be on certain port number, every node in the cluster is going to also have that particular service on that port number, but it will route it accordingly through this ingress routing mesh to the correct node. Okay, now let me now to get to the first aspect of our tutorial, which is the monitoring. So let me launch the CAdvisor monitoring tool. Let me launch the Manomax monitoring tool. I shall explain what is the advantage and disadvantages of both. So all the services, so this has been launched. Now if I see Docker service, PS visualizer, so I've called it visualizer, it is running, so, and it's on port 9000. So if let me just open a new window, and it is on port 9000 as mentioned. So yes, that's it. I should see the visualizer service running. Okay, it hasn't come up. Let me pause the video till it does. My apologies, it was actually not on localhost but the advertised IP of the master. But yes, so you can see that now the manager node is only running, the visualizer node is only running on the manager, and this is because of the constraint that I have set it to only run on the manager. And also port 8080 is published as port 9000 on the host system. So when I say service discovery, if I put 11, which is the IP of my worker nodes, it will also have this. So it's not going to have the service running on it, but it is going to route it accordingly to 10, which has the actual service running on it, which is my master node. So now what this visualizer tool gives us is it gives a simplistic view of which containers are running on which node, as well as what is the task so this is a task, what is the actual command running on, what is the image poll, and etc. So it gives a simplistic picture, which is very good for an initial debug tool. Now let's look at CAdvisor. So the CAdvisor is going to run in mode global, meaning all the nodes are going to run this, and it's going to run on port 8000. I mean, the published port is port 8000. So all services has to be launched on my master or the manager node, right? So this has been created. Now if I go to port 8000, So I see that all the three containers are running, and so yes, this is the advisor. So I can see the overall stats, that's the of the system, the whole system, what is the CPU, memory, etc., the utilization, a beautiful graph, and yep, and we can also see the containers. But yeah, so this is how C advisor works, and it's going to load balance. So now if you see, C advisor is running on one particular node. Now if I just refresh the page, it's going to load balance a request over to, yeah, so this is now I'm in the manager node, and it's going to be, so we see that visualizer is also running 92 168 9000. So now on, yes, so on the master you see that on the manager node two containers are running, these are the two containers, and we get a very detailed view of the system as such. So this is the beauty of C advisor, this is the advantage it provides, but the so it's little more detailed, it's not really a disadvantage, and compared to the visualizer tool. And the third monitoring tool could be just using the Docker API to execute Docker stats, right? So this gives me the memory and utilization, and this is what we are going to use for elastic container growth, which which is the next part of our thing. So to accommodate for elastic container nodes, elastic container growth, I have a Python script written, a client server script. This is the client, so I shall just run it, Python client py. So this is just going to send all its container utilization over to the server. So right, and to show the utilization also, I have to let me run a application called shopping cart, which is very simple. It's an Apache application. So let me, and it's going to be called cloud app, and it's going to run only on the worker nodes, right, and port 8080. So let me just run that, and before, right, so now this service is running, and let me look at the visualizer to see if it is actually running. And it's come up, you can see it is going to execute this command, and yeah, so it does not matter which IP I'm going, it should provide the service. Maybe it hasn't really come up, so let me give it a second till it does. Okay, so as you can see, now the shopping cart application has come up, and it is on the worker nodes now, and you can see that only one of it is running, which is, this is the shopping cart application, port 8080. And right, so now let's scale it up, right? Let's increase the load on this container. So I have used Apache benchmark tool, which will generate about 100,000 requests onto, yeah, the IP does not matter because it'll discover on its own, and yes, only the port is of concern here. So let me run that on my yeah, this is my stress test node, so it's starting the benchmarking, and it's going to send 1,000 requests parallelly. So let us watch. Before that has happened, I need to also run my server.py on my, because this is the thing that would scale the containers. Actually, this would monitor the clients as well as scale the containers. Both the clients are running it, and now the server is running it. So now you can see it has scaled to 2, right? And here the node 2 has not, it's not, so you can see container worker 1 has responded, worker 2 has also a particular container running on it. Before it didn't have, now it does have. So we can check it out, and you can see this, and it's scaling. Now let me kill the test, and it should scale down. So I've killed the test, and it should now idly scale down. Let's give it a couple of seconds till the scaling down happens, right? So I'll pause the video for a second or so. Okay, as you can see, it was at 7 from 564, and the utilization is now at 21. It's going down, and when it did go down, it's got scaled to 1. So now let us just go to visualizer and see that now, hey, only one application is running, and that is on this. So essentially our request will still be served. All right, thank you so much for watching, and I hope the session was